Hello everyone. Sometimes in mathematics we are given a very little yet expected to uncover something deeper. This is the question of such type. This is the question from JEE Advanced 2020. Here we know the trace of a 2 by 2 matrix and the trace of the cube of that matrix. So we have just fragment of information, but hidden within these fragments is the complete story of the matrix, and we are asked to find out the determinant of the matrix. It's a beautiful reminder that in mathematics as in life, small pieces often carry profound meaning if we know how to look at them. In this video, we will uncover and explore this idea by solving this same question in two different ways. One through the lens of the eigenvalues of the matrix, and the other by complete algebraic operations. So we have two perspectives to the same truth. So let's begin the journey of uncovering what is lying beneath the surface. As you can notice, the trace of a matrix is defined to be the sum of its diagonal entries, the information given, and we are given that a matrix A is 2 by 2 matrix. So the trace of A is 3 and the trace of A cube is negative 18. Then the value of determinant we have to find out. So the usual way, there is the method 1 I'm going to explain, but it's a lengthy one. So usually what we do, that the matrix we take as A, B, C, D as the entries, and we find out A squared by multiplying these two matrices together, and we get this is the elements, so these are the elements of A square. Further, we find A cubed, and since we need the trace of A cube, we don't find these two elements because we don't require it. So this is one actually important thing we can also keep in mind if we are doing this way. So once we multiply A cube, we get this two entries of diagonal, and we have to add them to find the trace of this A cube. Since trace of A cube is given, I substitute this value A cube. Trace of A cube is negative 18. And also notice that the matrix is A, B, C, D. So the trace of matrix is A plus D. So wherever we see A plus D, I have to substitute the trace of that matrix that is given 3. So A plus D is going to be 3. So we are just adding these two entries to find out the trace of A cube. And we club the elements in such a way that we find out the piece A plus D to substitute with 3. So here we can see that this is the first element we wrote. By taking this BC common, this we get it, because B we can take it common here. So we get BC out and A plus D. Similarly, here we can take C common, so we get A plus D. And so each A plus D I am replacing with 3. This will become 3BC and 3BC. And again, I'm clubbing this A cube and D cube together. And this is going to be BCD and ABC together. So from these two, BC is common again. So I have A plus D, and again BC times A plus D, 3BC, and just 6BC, so 9BC. A cube plus D cube, I will apply the A cube B cube formula. A plus D, A square plus D square minus AD. Where A square plus D square, I can write A plus D the whole square minus 3AD plus 9BC was already there. And after that, we simplify further, and we get this 9 times AD minus BC, and AD minus BC is nothing but the determinant of the matrix. And so we get 9 determinant of A is equal to 45, so determinant of A is 5. This is the usual way to solve it. But what we can do better, let's try to understand. So the idea is the eigenvalue. So we know that if I have a 2 by 2 order matrix, the characteristic equation A square minus trace of A times A plus determinant of A times I is equal to 0. So this is our characteristic equation. By the way, characteristic equation is lambda square minus trace of a, let's say S lambda plus determinant of a, the delta I. This S is, I'm calling sum of the entries, diagonal entries, so that is actually trace of A. So in this way, this is the characteristic equation, and every characteristic equation is satisfied by the matrix itself. So I know that this is the A square minus trace of A times A, determinant of A is equal to 0, is a matrix, is an equation satisfied by the matrix A. Now, since we have to find out the determinant of A, and also we have to involve the A cube, what we can do here, we can substitute these values first. So we know that trace of A is already given, that is 3. So I can write 3A, and plus determinant of A, I can write as it is. Now I multiply this entire equation by A. So we get A cubed. And at the same time, I'm bringing both of the terms to the right hand side. So I'll give you 3A squared minus determinant of A times A. Because I multiplied with A, so I times A will become A. Also, I have to find out the trace of A cube because I have to use it. So what I do, I apply the trace over here. So once I apply trace, so trace of A cube, and you notice when you multiply any matrix with a constant, each entry will be multiplied by that constant. So trace will be also multiplied that fold. So we simply say that 3 times trace of A square. And here also determinant of A is a number, so it will act as the same property. So determinant of A times trace of A. But notice the trace of A already we know, and trace of A cube is already given. So I can write negative 18 as the trace of A cube is given. Trace of A square I don't know, but we can find it out. Trace of A is already 3. So we can write 3 times determinant of A. Now, if we can find out the trace of A square, our work will be done. So what I do, again I use this star and apply the trace over here. So what I'm going to do is, since we have what we have, A square is equal to 3A minus determinant of AI from this star. And again I'm applying the trace here. The trace of A square is 3 times trace of A minus determinant of trace of I. Notice here the trace of A is already given to us, that is 3. So it will become 3 times 3, 9. And here determinant of A as it is, and trace of I, because matrix is 2 by 2 order matrix. So trace of I will become 2 because diagonal entry sum will be 2 for the identity matrix of 2 by 2. So that will become determinant of A times 2. And this value I can substitute in the first equation. So what we get it here is negative 18 is equal to 3 times 9 minus twice of determinant of A minus 3 times determinant of A. And from here, we can evaluate the value of determinant of A. How? This is a negative 18. So 27 minus 6 determinant of A minus 3 times determinant of A. And so we get 9 times determinant of A is equal to 45. And so determinant of A will be 5, and that's our answer. So in this, we don't have to multiply or assume the matrix as we did in the first method. There is another way also to do this thing. Let's also understand that one. So what we can do here, let me write first another way. And that is quite quicker than previous two but that is not actually in the syllabus. Even that is also not in syllabus, but usually we teach and students know this fact that the characteristic equation and all this properties about it. So here another way is what? If I say that the summation, or let me write like this way, a trace of, basically what is happening, the trace of A is what? Trace of A, what you are doing is summation of all the delta I. Delta I means delta, not lambda, sorry. Lambda I are eigenvalues or eigenvalues, whatever you say. Eigenvalues. So lambda I are eigenvalues. So trace of A is always the sum of eigenvalues. What is the trace of A square? So let me write directly. Trace of A to the power n is the property, the sum of the eigenvalues of A to the power same n. The meaning is that suppose the trace of A is sum of the eigenvalues of A, then the trace of A square is sum of the same eigenvalues of A squared. Means sorry, the sum of the square of it. So how we can use it? And also notice one thing, there's one property more, is if this happens, then this happens. And the second property is the determinant of any matrix is the product of the eigenvalues. So let me write like this, pi, or I can generalize it, delta 1. I am saying delta lambda 1, lambda 2, lambda 3 up to how many eigenvalues we have. So what we can assume from here for that question, let's understand. So since what I have given, please understand, they are saying that the determinant of A, we have to find it out. They say that the trace of A is given as 3. So it means that since the matrix has order 2 by 2, so this matrix must have 2 eigenvalues. The 2 eigenvalues means the sum of the eigenvalues I have given. Because the characteristic equation lambda square minus, when you write here, trace, and then trace lambda plus determinant of the same matrix into I is equal to 0. So you can notice from here also this t is actually standing at the sum of roots, and this delta, the determinant, is standing at product of the roots, which is already there. So here what we can apply, or what you can do is lambda 1 plus lambda 2 is 3 actually, not 0. 3. And the determinant I have to find out lambda into lambda 2. This we have to find out. So what I do, we know that also given the trace of A cube, and trace of A cube, what you can write is lambda cube plus lambda 2 cube. It's lambda 1 cube plus lambda 2 cube. And that is all given negative 18. So what I can apply here? I can apply simply here that the lambda 1 plus lambda 2, A cube plus B cube formula, lambda square minus lambda 1 lambda 2 plus lambda 2 square is equal to minus 18. And notice what will happen after it. Lambda 1 plus lambda 2 is nothing but 3. Lambda 1 into lambda 2 I have to find out. But this I can write lambda 1 square plus lambda 2 square is lambda 1 plus lambda 2 the whole square minus 2 lambda 1 lambda 2. So I can write directly lambda 1 plus lambda 2 the whole square minus 3 lambda 1 lambda 2 is equal to negative 18. So this will again become 3. So 3 plus 3 square is 9. So 3 times 9 minus 3 times lambda 1 lambda 2 is equal to minus 18. And from here we get 9 minus 3 lambda 1 lambda 2 is equal to minus 6. And so 3 lambda 1 lambda 2 is equal to 15. So lambda 1 times lambda 2 is equal to 5. That is the exact what we have to find, which is because lambda 1 to lambda 2 is determinant of the matrix. So if you know this property of the characteristic equation and how the eigenvalues fit into the equation, then we can easily find it out. You can see if this was the question from advanced 2020, and in this they have given the matrix up to a cube, means that the trace of the matrix a cube they have given. But what will happen, suppose they ask you the matrix of A4, like matrix, like this is the question here. So let's try to understand. The question says that if A is a matrix of 2 by 2 order whose trace is 3 and the trace of A to the power 4 is 81, then we have to find out the determinant of A. So what will happen? Let's try. So we can apply either this better approach or better way, or we can apply the another way. We say that apply the method 1, method 2 or method 3 we can apply. So let's apply the method 3 and see how it's profound. So we know that lambda 1 plus lambda 2, because a 2 by 2 matrix, we know the trace is 3, so I can take like here. And now I can write it here. Lambda to the power 4, lambda 2 to the power 4 is equal to 81. This I can write lambda 1 square, lambda 2 square, the whole square minus 2 lambda square, lambda 2 square. You notice I have to find out this quantity. Now here I can write again lambda 1 plus lambda 2, the whole square minus 2 lambda 1 lambda 2, and minus 2 lambda 1 lambda 2 the whole square is equal to 81. You notice here I have to find out lambda 1 into lambda 2. So what I'm assuming, lambda into lambda 2 is a number, let's say x, that is the determinant of the matrix A. So this lambda 1 to lambda 2, lambda 1 plus lambda 2 is 3, so 9, minus 2 times x minus 2 times x square is equal to 81. So from there what I'm getting is 2x square minus plus 2x and minus 72. So from there I can take this 2 out. So x square plus x minus 36 is equal to 0. I think I have done a mistake here. That should be lambda, that here, that is actually one mistake. Let me correct it. That is okay, no problem. But here what I meant to write is lambda 1 plus lambda 2 the whole square minus 2 lambda 1 lambda 2, and this is whole square. So this is going to be 3 square, that is 9, and this is 2x the whole square minus 2 x square is equal to 81. 9 9 is 81. Oh no, 9 4 is 36. 36x and plus 4x square minus 2x square is equal to 81. 81 get cancelled. So I'm getting 2x squared. So x and 2x minus 36 is equal to 0. So x equal to 0 and x equals to 18. So these are the two solutions we have. Means determinant can be 0 also and 18 also. So this is the profoundness of this method, that we don't have to assume a matrix and multiply them 2 times or 3 times or 4 times. All right. So I hope this video added some value to your learning. So see you in the next videos with some other such questions with depth understanding of some method. Till then, stay math active.